When something vibrates melodically, it's also vibrating at various frequencies that are multiples of its base frequency. That's what the harmonic series is. Timbre, or the qualities of a sound that differentiates one thing playing the same note from another, is caused by the variations of how loud each of those frequencies are, and usually the higher frequencies get quieter the further they are from the base frequency. A sine wave is a representation of a single frequency, and the sound you get from a single sine wave is an example of what anything would sound like with just its base frequency, and without overtones or timbre. In additive synthesizers, you'll see the harmonic series represented by a bunch of lines that increase or decrease the volume of individual sine waves, making up a sound's overtones. There's also often a mirrored side below that changes the phase of each individual sine, which is the position a waveform starts at. When making sounds through additive synthesis, it's good to know for reference, a square wave is typically formed by applying every odd frequency in the harmonic series to the base frequency, while the saw wave is typically formed by applying all of the frequencies of the harmonic series. But we can also get completely different waveforms by changing the amplitude of the various harmonics or overtones in different ways. For example, the next most common wave you'll come across is the triangle wave, which uses the same harmonics as a square wave, but it looks and sounds different because its overtones drop off in amplitude at a different rate. Now let's talk about distortion and how this can matter in sound design. When you distort something, you're adding frequencies along the harmonic series of every already existing frequency, typically adding the odd frequencies when the distortion makes a square-like shape or causes clipping. You probably already know about perfect fourths and fifths, or power chords, and how these are intervals that sound good with distortion while everything else tends to sound bad. That's because the frequencies in power chords line up with each other's harmonic series. But if you step outside of standard tuning, you'll find there's a number of other intervals that also harmonize with distortion. If you tune them just right, they can also be distorted for unique synth sounds.